So answer key for 1.2, functions and graphs. Area of a circle, area given r is pi r squared. Now I know that r equals d over 2, so if we replace that, we become a of d equals pi d over 2 squared. And the area equals pi d squared over 4. Now they say, what about a of 4 now is pi 4 squared over 4, which is 4 pi. And normally I'd say units, but there are no units given. Never mind, I lied. Inches squared. Surface area, s of a cube, is a function of the cube's edge. Well, there's 6 sides to a cube, and each edge has an area edge squared. So the surface area of a cube, surface area given its edge is 6 times e squared. So what's surface given a cube length of a edge at length of 5? 6 times 5 squared equals 150 feet squared. Identify the domain of range and sketch the graph. Well, this one is just -9. Domain, since it's a function, well, that's not true. Domain of this case is everything. The range is -9 to infinity. Now, this gets dicey. I happen to know that square root of x does this. And if we put negative on the inside, it flips it across, I believe. Yeah. So we go to and then get all the way down here to the answer, which is, I don't have to write that, which is down here, because the negative out front flips it down. Domain, -infinity to 0. Inclusive, should be a blocky one. Range, same deal, -infinity to 0. Fourth root of -x. Interesting. So it's just like square root, except it's going to be flatter or something. I could graph and find out, but the -x just flips it over here. Domain, -infinity to 0. Range, -infinity to 0. Sorry, my brain is trying to go into autopilot mode, and I can't allow it to do that. 0 to infinity. Y equals 1 plus 1 over x squared. All right, well, I happen to know that this is y equals 1 over x squared. It's just like 1 over x, except that the other side is positive. And I know I'm a nerd, but you should also try to lock some of these down, maybe write them down on a sheet of paper. Now we move this up to y equals 1, because we added the 1. And that's it. Now the domain, -infinity to 0, not inclusive, 0 to infinity. And the range starts at 1, but doesn't touch 1 and goes up forever. Yeah. Yeah, it's cool little math. I kind of like that. And continue with that. I'm just a little nervous. I sometimes forget to look at my screen. Assume I showed all that work. Yeah. Equals 2 root 3 minus x. This looks hard. So that's like negative x plus 3. It's actually like parentheses, negative x plus 3. Nah, I just have to guess and check on this. I mean, not so much guess and check as I would have to graph it and see what's going on. Square root is still going to do that. The negative inside is going to flip it backwards. 3 is going to move it 3 to the right. Let me check that out. 1, 2, 3. Plug in 3. 3 minus 3 is 0. Good. Plug in 4. 3 minus 4 is negative. Can't do that. So there we go. Plug in 0. 2 times square root of 3. I get whatever I get. Okay. So there we go. Domain, negative infinity, all the way up to 3 inclusive. Range, 0 inclusive to infinity. Nice. Now, I showed this one in the video. If you don't know, you can square both sides. Move the x squared over. And oh, that's just a circle. But since there's only a hidden positive up here, you don't put the other side in. So when you graph it, you just do this. There's no arrow there. It's just a point. And it goes 3, negative 3, 3. So domain is negative 3 to 3, both included, and range is 0 to 3, again, both included. Yeah, look at that, I did it right. What equals x to the 3 halves? Well, I put a negative 4 in here. Square negative 4, I cannot. Negative 4 to the third is negative 64 square root. I can't, so I can't put negative values in here. Otherwise, it's kind of like an x squared function. Whatever. I can put in 0. Domain is 0 to infinity. The range is 0 to infinity. Cool. And over here, this is pure practice. You might want to put in your calculator. Actually, I'm cheating a little bit. Looking at the bottom, I can't put in 3, but I can put in 2. No, I can't put in 2. I'd have a hole at 2. I'd have 0 on the bottom, which would be an asymptote. So at 2, I have an asymptote. Negative 2, I have an asymptote. And it comes down here pretty low. At 0, I get 1/2. So it's here at 1/2. All right. So domain is not including negative 2 to 2. Range is including 1/2 to infinity. I'm looking at my notes and I made a mistake on them. And nobody ever yelled at me. Well, I'm glad I found it. So, again, I'm concerned I did not show that because I forgot to look at the screen. No, I got lucky. Okay. Remember whether the function is even or odd or neither. I don't answer analytically, so I'm going to ignore my own advice. This has got an odd and even together, so I know it's not going to work. And it does some weird graph like this. So it's neither. And if you want to do analytically, you go right ahead, plug in 1, and you get out 2. Plug in negative 1, and you get out 0. So you should get the same when you plug it in. Now this should work. So I plug in 1, I get out 2. I plug in negative 1, I get out negative 2. Okay, that should work. So let's see what it looks like when I graph it. does I call it the changing lanes, loops up. So that's going to be odd because it's got point symmetry. I can spin this page, it looks the exact same. Now here, this should be even. I don't know what it looks like when I graph it. I don't know the bottom factor, so it's going to have asymptotes at 1 and -1. Play with it, and I get something like, let me think for a second. If I put a massive number here, 1/10,000 minus 1, well, it should stay above. Bothers me when I do something wrong in the past, and nobody ever yelled at me. So something like this, and something like this, which makes it even, and then something like, plug in 0, I get -1, something like this. That makes it even. And then this, no matter what I put in, positive, negative, I'm going to get something similar. This is kind of cool. This actually looks a lot like the absolute value. Plug in 0, I square root of 2. So this is 1 and this is 2. It hits about 1.4. Goes up, and here it goes up. That is even. Again, making sure everybody can see my work. It's been a long day. I'm not thinking clear, but I'm doing my best. Graph the piecewise, identify the domain and range. So when x is less than 1, we get 4 minus x squared. That's negative x squared plus 4. So it's an upside down graph. So at 1, we put in 0, it hits at 4. Here, if I put in 1, I get 4 minus 1 is 3. So, and that is an open dot. That's everything less than 1. So off we go. Nice, did something right. Okay, and then put in 1. I get 3/2 plus 3/2, which is 6/2, which is 3. Ooh, it's in the same spot. Cool. And then it's graph up to the right. Put in 3. 9/2 plus 3/2 is 12. Over 2 is 6. 1, 2, 3, 4, 5, 6, about here. And they both have equal signs, so dots. X plus 3, 1, 2, 3. Plug in 3, I get 6, just like I did there. And now I just put a 3/2 is a steeper slope, so it's going to be a little bit more shallow slope. Nice. Domain, everything. Negative infinity to infinity. Range, same deal. Negative infinity to infinity. Neat. And over here, x is less than 0. X squared. From 0 to 1, not included here. Huh, that's a little weird. So I'll go right here. It goes here. So 1 goes to 1. 1, 1. So is that, ignore that little smudge there. And then plug in 1, 2 minus 1 is 1. And it's going up. Yeah, and it does this. Pretty steep. Okay, so domain is negative infinity to 0, not inclusive, 0 to infinity. And range is not inclusive, 0 all the way up to infinity. And let me make sure I'm happy with that. Yep, looks good. 8. Graph the equation shown, determine if it is a function. All right, this is a ellipse. It's not a function. So I can put in different numbers, get different answers out. The cool thing is we can break this into parametrics, and each parametric is a function, so we can do calculus on it, which is bizarre. I don't know who thinks of these things. They're just insane in my book. 1, 2, 3, 4, 3, 1, 2, 3, 4, 2, 3, and here we go. So not a function because you can see the vertical line test is broken. So over here, we will do the GIF function. And for those that haven't seen GIF, It is a function. It's a jump function. It looks like this. And this is a good one for calculus because we can talk about limits, continuity, and point continuity, and all that stuff. It's a function because every hole has a dot above it. And it's called the greatest integer function. And I am going to have to graph this. It's going to take forever to boot up my calculator. And I don't think you can see it until it finally comes up. I'm honestly not sure how to graph it. So I believe I share screen with the calculator up. There we go. Go to y equals, which has some crap left over in it, clear. And math. No. Under number, int. Yeah, it should say GIF, but it doesn't. And even this one doesn't work real well in that. By the way, this is the X button right here. You really should learn to handle that. And it's going to just show a bunch of lines. There it goes. Doesn't show the dots and the open circles. Yeah, so you should know that. You should definitely know that. But it is a function because all the dots and the holes line up on top of each other. All right, and then write a piecewise formula. So I'm just going to write the answer. You're going to have to figure it out. This line and this line and this line. So we're looking at 1/2 x from -2 less than or equal to x. That's a closed dot. It's hard to tell. That's a closed dot. Yeah, the little extra gray. Open, definitely. If you're not sure that it's open, it's closed. Pretty crappy graphics, but it's the best I could do at the time. And then this is going to be some -2x plus 2. And that's from 0, that looks like a closed dot, less than x less than or equal to 1. And then this is y equals -1. And that is from 1 less than x less than or equal to 3. Cool. And over here, we have f of x equals -1/2 x minus 1, -2, open dots, less than x less than 0, and then slope -3/4 plus 3, and that's, I think they're closed. It's hard to tell. Let's assume they are. 0 less than or equal to x less than or equal to 4. Dicey, but doable. Just making sure you know piecewise. And then graph the function and find the domain and range. Well, we've been doing a lot of this, haven't we? All right. Plug in 0. It's here at -1. Plug in 3. It's at 2. All right, and it goes that way. And then once you plug in something bigger, the absolute value kills it, and it's on its way down. It's a negative slope. Cool. So domain, -infinity to infinity. Range, -infinity. What did I say? Plug in 3 as high as 2 inclusive. Making sure you know your absolute values. Plug in -4. We get -3. That goes up twice as fast on both sides. So I'm not exactly sure where it hits here. 1, 2, and over 1. Yeah, it should go halfway. Like that. And something like that. Doesn't really matter. Domain negative infinity to infinity range. Plugged in -4, I got -3 inclusive to infinity. All right, cool. So we've got a ton of composite functions here. This gets real busy real fast, so I'm just going to blast through it. F of g of x equals x squared minus 3 plus 5 equals x squared plus 2. G of f of x equals x plus 5 squared minus 3 equals x squared plus 10x plus 25 minus 3, x squared plus 10x plus 22. F of g of 0 equals -3 plus 5 equals 2. F of g of f of 0 equals 1 squared (5 squared), right, minus 3 equals 22. F g of -2, this freaks people out, it's really not a big deal, equals -2 squared. Yeah, -2 squared, which is 4 minus 3, which is 1. -2 squared minus 3, which is 1 squared minus 3, which is -2. And then f of x equals x plus 5 plus 5 x plus 10. I think I mentioned it before, I'll mention it again, you're never going to have to do that. You are going to have to understand composite functions, but I never break it down that way. I don't think it's helpful. So I'm just going to fill this in, and if I were you, I'd try this first. X squared, because you plug in f of g of x means plug in x squared there, and then it just shows how that works. F of g, and you should never do fog because it's just not helpful, it's just more confusing, equals x squared minus 5. This is just me showing you what's going on there. And here I'm going to guess it's 1 over x minus 1. And the way I did it was 1 plus 1 over g of x equals x. So minus 1, flip, g of x equals 1 over x minus 1. Tricky. And then here, 1 over x. And f of x equals 1 over x. So f of g of x equals 1 over x equals x. And then, last but not least, I forgot to write it in. That's very upsetting. X squared. So f of x equals x squared. F of g of x equals square root of x squared. And we say, hey, that's just x. No, that's the absolute value of x. It's always positive. And I can't put a negative number in the middle because of the square root. Whew! Breaking a sweat doing math. Happy mathing.